All right, here we go. Let's try to finish 1-1, and we'll call it 1-1b. So we left off with, what, the addition properties, right? So now we're going to do the multiplication properties, and you'll see some of the same words. So let's take a look. So now we're doing multiplication. So write this down. It helps you stay awake a little bit. I know it's getting towards the end of the day. It's a little bit warm in here. The other class I was complaining it was too cold, but now it's too warm. All right, so let's do this. Let's do that commutative property again. Do you remember the commutative property of addition? What was it? A plus, you should have it in your notes. Right, A plus B equals B plus A. So question is there a commutative property of multiplication? Which would mean what? A times B equals B times A. Yeah. So does it matter what order that you multiply things in? No, it doesn't make any difference at all. Is there a commutative property of division? No, because is 4 divided by 2 the same thing as 2 divided by 4? No, it's not. So there's no commutative property of division. What about subtraction? We talked about that yesterday. 5 minus 2 is not the same as 2 minus 5, but multiplication, yes, there is a commutative property. I'm not going to use the word property every single time, but you could put that on there, okay? It's called the commutative property. Let's just write A times B equals B times A. Very good. All right, let's do associative. Again, if you look at your notes, you should see what associative property is. So this time we're multiplying like 3 things together. A, I'll put a dot here, times B times C, and then I'm going to put an A times B times C here. Now you're doing 3. Do you really ever multiply 3 numbers all at the same time, the same exact time? No. You usually do 2, right? I guess some people with higher capacity of learning maybe could just do all 3 at the same time, but this is what we usually do. Is this the same as this? Yeah, absolutely. Okay, so I can multiply the first 2, get an answer, then multiply it by the third one. Or I can multiply it by the last 2, right? Multiply the last 2 together, then multiply it by the first one. Or if I wanted, you can't really do this with parentheses, but I could multiply A times C, right? And then multiply that by B. All right, so yes, associative property does work with multiplication just like it does with addition. All right, what was the next property we had? If you're looking at your notes, you should see it. Identity. What was the identity property for addition? It was the 0. You added a 0. So what did that mean? It means it didn't change your identity, correct? Right? It didn't change the number, the original number. So, 3 plus 0 is equal to 3. That's the identity. What do you do in multiplication so that what you end with is what you started with? You multiply by 1. Exactly right. All right, so let's see how they write that. Yep. A times 1 equals A. So that's considered the identity property. All right, because whatever you started with, if I do something to it, you're going to end up with what you started with, right? And if you multiply it by 1, it's going to be the same exact thing that you started with. Yeah, pretty easy. Inverse. Inverse on addition, what did we do? The inverse property. What did we do to A when we did the inverse? Like what's the inverse of adding something? Negative. Subtracting something, okay? So what's the inverse of multiplying by something? Dividing, right? Or this, watch. I guess they could have used other letters, but they're going to do this. So A times, what's the inverse of A? It's 1 over A, right? The reciprocal or inverse. When we talk about the multiplicative inverse, we're talking about flipping it, okay? So what's the multiplicative inverse of A? It's 1 over A. What happens when you multiply a number by its multiplicative inverse? What do you get? You get a 1. That's right, every single time. You can put regular numbers in there if you wanted to. Put 7, all right? Multiply it by its inverse. What's the inverse of 7? 1 over 7. What are you going to get? Every single time. You can put any number in there. It's always going to do that, okay? So that's the multiplicative inverse. The other one we did yesterday, when they added up to be 0, that was the what inverse? So if I want to go fancy and say multiplicative, what am I going to say for the other one? If I add it to its negative, additive inverse, right? It's called the additive inverse, all right? And distributive property kind of works for both, all right, because you do some addition, you do some multiplication. We'll just do that. We might as well write it down. Distributive property. So it's just A times B plus C. You've done this. Yeah, but I said it's kind of the same for addition and multiplication. So it is a multiplication property because you are multiplying. So it's AB, what, plus AC. So there's still addition going on, but there's also multiplication going on. Everybody good with that? All right. By the way, let's throw another vocab word in there, that multiplicative inverse, this thing right here. We have another word for that. Do you know what the other word for that is? Well, it's not just a fraction. It's a specific fraction. It's the reciprocal. So that one right there is called the reciprocal. Reciprocal. Okay? So if I said multiplicative inverse, that's a mouthful, right? Reciprocal is a little bit shorter, a little bit easier to say. All right, so most of the time we would say that, multiplied by the reciprocal. So what if I had this? What if I had 4/3 instead of just a whole number? What's the reciprocal or the multiplicative inverse of 4/3? 3/4. And what do you get? You still get 1, okay? It works even when it's a fraction. Everybody got it? Okay, doke. All right, so they just, I'll just do this real quick. This is example 3. If you're looking in the book, following along, this is part A. It says, I'm going to give you something, and you tell me what property. Okay, we did a whole bunch of properties, and I want you to tell me which property is being shown right here. It won't be quite as simple as like just the A plus B or A times B. It's a little bit more stuff, but it's the same idea. Equals. All right, so what property is that? What's that? Commutative, right, of addition, right. It's the commutative property of addition. So that's what they're expecting to write down. So they might have some problems like this on the homework. I don't even think I put anything like this on the quiz or the test, all right? But at least, this is just the very beginning. It's the very first section. So I think sometimes it's good to know these properties because they might have them in definitions and stuff like that. They may talk about them. So we need to know at least what they're talking about when they say, oh, the commutative property says this. Now in geometry, remember I told you about geometry last year? What's the thing that I kind of didn't do and I almost felt guilty about not doing? Do you remember? And I said, you should be very glad that I didn't do this. Proofs, right? Now, if I did like hardcore proofs in here, you would use commutative, associative, all that kind of stuff all the time, all right, in geometry. So it is used a lot, but I took it easy on you guys and I just kind of stayed away from the proofs. No. We didn't even do proofs in geometry. Now I used to, back when I taught, before my little break, 10-year break, I taught proofs all the time. But the more and more I think about it, and the more I see what you're going to be doing in college and your testing, you're going to have like the SATs and stuff like that. They really don't do proofs on there. They just like solve for X, right? You got a parallelogram. They tell you some angles, right? You set the angles equal to each other, or you add them up, set them equal to 180 or whatever, then you solve for X. To me, I think that's a little more important. And so I just think we kind of got bogged down in the proofs. But if you're going to be a math major, I was a math major. And it was not an easy thing for me. But you do a ton of proofs, a lot of proofs. So if you're going to be an engineer, you're going to do something, or an architect or a computer scientist or something like that, and you still got to do a lot of math, you probably won't do many proofs at all. You just learn how to solve things, you know what I mean? So that's what I tried to do in your geometry class last year. Anyway, enough of that. So that's commutative property. If you want to write that down, you can. All right. What about this? 3b times 1 over 3b equals 1. All right. That's what? Yeah, but what's the big word? What? I said it a bunch of times. Multiplicative. That's a fun word to say. Everybody say it. Ready? 1, 2, 3. Oh, come on. Ready? 1, 2, 3. Multiplicative. Isn't that cool? Plicative. It just rolls off the tongue. I like it. All right, enough of that. All right. That's a multiplicative inverse. Or you could say reciprocal, right? Multiplicative. Well, I'd just say reciprocal, I guess. 5xyz plus 0. This is almost a waste of time. I should keep going. 5xyz. All right, what's that right there? That's identity, right? Addition, identity of addition. xyz. Yep, 5xyz plus 0 equals 5xyz. Yep. So when you add something, that's the identity, right? Because we didn't change it, right? You still stay the same, right? Remember we talked about looking in the mirror kind of thing, and you see, your identity. You don't change, right? You're still the same person. All right. Enough of that. Let's just keep going. It's almost a waste of time. Let's see what I want to do. I hate the beginning of algebra books because they go through all this stuff. I like to get into the meat of things, you know what I mean? And let's start solving something. I want to find what x is, right? We're always looking for x. That's what I like to do. So this is just just got to get through it kind of stuff. That's how I feel. I know math teachers aren't supposed to say that. They're supposed to act like they're all excited about every little topic, but this is the part of it that I don't really care for. All right, it's close to perform the operation as members. All right, you'll probably be asked about this, so we might as well do this. I'm just going to write this down. I'm not going to write out the whole definition. A closed set. All right. So if a set is closed, let me read off the definition. It's probably right in the book because that's where I probably got it from. So the set is closed under an operation if the result of performing that operation on members of the set always results in a member of the set. You're like, that still doesn't help me. I have no idea what that means. I'll give you an example. So we learned yesterday about whole numbers, natural numbers, didn't we? We did all that stuff, right? All right, so that's going to come into play right here. So they're going to ask you, is it a closed set or is it not a closed set? And I'll do an example. I think that's a lot better than the definition because the definition just blah, 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 blah. That's all I hear, So example 4, is addition, is addition a closed set? I'm going to read the definition one more time, okay? Set is closed if that operation on the members of that set always results in a member of that set. For instance, if I add up two integers, 2 plus 5. This is an integer, this is an integer, okay? I'm adding things in the set of integers. You with me? What does the definition say? The result is going to be an answer that's in that same set. So my answer has to be a what? An integer. Exactly right. So is addition a closed set? Does it fit that definition? Yes, it does. If I start with an integer and I add another integer and my answer is an integer, then guess what? It's a what? Closed set. So what's my answer? Should be a question mark here. Is it a closed set? Yes, it is. Okay. Let's try another number. It might be a little bit tougher. Let's go like negative 2 plus 5. What's negative 2 plus 5? They're all integers, right? Okay. If that's an integer and that's an integer, is my answer an integer? Absolutely. Okay. Can I take two integers, add them together, right? Because this is addition. It's asking about addition, and get a irrational number? No. Okay. Can I get a... What's the other one? What's the other one? Can I get a fraction out of it if I add two integers together? No, I can't. So I'm always going to get an integer. Now, what's under integers? Under integers are what? Natural numbers and whole numbers, right? So that's still considered in the set of integers. Make sense? All right. So what about this? What about subtraction? So is addition a closed set? Yes, it is. That's my answer right there. That's supposed to be an exclamation point, okay? The second problem says, is subtraction closed? Is still example 4, okay? It's just part A, part B, all that stuff. Is subtraction a closed set? So let's do this. Well, let's do this. What if I had 5 minus 2? What's that? That's 3, okay? Integer, integer, integer. Looks like it's a closed set, right? But what if I did this? What if I did 2 minus 5? Now, it does work for integers, but does it work for the subsets of integers? So what's the answer to this? It's -3, okay? So this, again, we're looking at subtraction. This could be considered a whole number or a counting number, yes? This could be considered a whole number or a counting number. Is my answer a whole number or a counting number? It's not, okay? You follow me on that? All right, so it's kind of weird. I know, I get it. So is subtraction closed? No, it's not closed. Boom, okay? What about multiplication? Yeah, because if I said 2 times, let's see, -3, that's what? -6. So I don't know if my explanation on that was really good. Anyway, it is, yes. Okay, so if that's an integer, it creates an integer. But then I could say the same thing. Here, that's an integer, that's an integer, that's an integer. See, that's where I'm getting a little, I don't know. But they say multiplication is closed. What about division? I'll just give you an example. Watch, 12 over 3. What's that equal to? It's equal to 4. So that's fine, right? Integer, 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 or natural, natural, natural. Okay, what about this? 3/12. What's 3/12 equal to? It's 1/4. Okay, this, yeah, natural number, natural number. What's that? Is that a natural number or a whole number? No, it's not, okay? So is division closed? No, it's not closed. All right, enough of that. That's, again, this stuff, I can't wait till we do real math. Tell you the truth. Let's do one more example and then we'll be done. Let me see what time we got. 2:05. Oh, wow, I got plenty of time. I thought we were running short. All right, so we got one more example and then we'll be finished. So I'll give you some time to work on this homework in class. That'd be nice, if you think you can handle it. It says, determine whether this set, all right? So everybody watch this. -1, 0, 1. Well, it says, determine whether this set is closed. Is it closed under these two operations? So is it closed under addition? This should make a little bit more sense, okay? So I can take any combination of these and add them up, okay? And so if I start off, we just want to see if it's closed or not. So I see what they're doing. So that means if I add any of those two numbers, if that number is still in that set, then it's closed. If the answer, when I add any of those two numbers together, is not in that set, then it's not closed. I said that quick, but I think I said it pretty well. Okay, so let's add up any of the numbers. So let's add up. These are the only numbers we're allowed to add up, right? These three. So let's go -1 plus 0. What's that equal to? -1. Is -1 in this set? Yeah. So far it's closed, isn't it? All right. But we got to do every combination. What about 0 and 1? What about 0 plus 1? What's that? That's 1. Is 1 in this set? Yeah. What about negative 1 plus 1? What's that? That's 0. Is 0 in this set? Yeah. So far, it's closed. But there's one more. Well, there's actually a couple more. You don't have to just do each individual one. You could add them to itself. So let's take that 1 right there. What if I go 1 plus 1? What's that? Is 2 a member of this set? No, it's not. So just having one thing where the answer is not a member of that set, that means it's not closed. Okay? So, yeah, so you would just say, this is not a closed set. All right? It's as simple as that. Let's do one more. We'll be done. Multiplication. Oops, part B. That's supposed to be a B. It's terrible. Multiplication. Let's try the same thing. Let's do it. Negative 1 times what? Doesn't matter. Pick one. Let's go 0. The one right next to it. What's that equal to? Is 0 a member of that set? Yeah. Let's go negative 1 times 1. What's that? Negative 1. Is that answer a part of that set? Yeah. So far, so good, right? What else could we multiply? What about negative 1 times itself? That's positive 1. Is that answer a member of the set? Yep. What else are we missing? 1 times 1? And that's 1. Is 1 a member of that set? Yes. One more. 0 times 0, right? What's 0 times 0? 0. Is 0 part of that set? Are there any combinations of these numbers? If I multiply them together, my answer is not part of that set. No. So what is this? This is a closed set under multiplication. Okay? So yes, it's a closed set. So it's closed under multiplication. So yes, this one is closed. This one is not closed. That makes a little bit more sense, doesn't it? When you actually have something like that. And that's probably the kind of stuff that they're going to ask. Because every answer is in the set that they told us it was going to be. I did a terrible job explaining this thing right in here, but I think this helps a little bit right there. Everybody good? Confused everybody already? All right, so let's put your homework down. So this is what I want. When you do your homework, I always want the section number. First of all, full name. I should have said this to my other classes today. I want your full name. That means first and last name. Please print it so I can read it. All right? So first and last name. Then I want the section number. So it's going to be section 1-1. And to tell you the truth, I really don't care if you put the page number on there. You can if you want to. I'll put it here so you know what page it's on.
Wait, do we have to write on the left side or right side?
Right side.
Wait, can I write along the top?
Yeah, I really don't care if it's left side or right side. As long as it's at the top, okay? As long as it's at the top somewhere, you can put it in the middle. I don't care. That's fine with me. But I do want to make sure you put your full name, first and last name. You guys are getting older, okay? We're not little kids anymore. In elementary school or middle school, you can put your first name, Johnny, as long as there's no other Johnny in the class. And then that's fine. But as we get older, nobody ever just writes their first name. Okay, if you work in a business and stuff, you always write your first and last name all the time. Just trying to get you used to that. Okay, just being a little bit more professional. So write your first name, or first and last name, full name, definitely right there. If you don't have that, it's a point off. If you don't have that, it's a point off. Everybody got it? Okay. You don't have to have the page numbers, but I'm going to put it on here anyway. It's just page 5, and it's 1 to 32. That seems like a lot, but these are super easy. And you have like 20 minutes in here to work on it. When did I say it was? 10 after? 5 after. You got 15 minutes, okay? And it has to be in what? Pencil. Okay? And it has to be not torn out of a notebook. Okay? See all these things with stars? I will take points off for all that stuff. All right? 1 point off for any one of those things.
Wait, it can be torn
All right.
if it doesn't have like
If you got the even, if it's nice and straight, Okay, I don't mind the perforation thing, all right, as long as you don't throw the frilly things on the floor. But it can't be turned out, or it can't be torn out. What's another thing I would, well, if it's late, let's say it's late. If you're late, it's a -2. Not -1, it's -2. And I'm only giving you 1 day to be late. Last year, I let you turn in stuff late. I still took more points off. But I'm giving you 1 day. 1 day grace. That's it. But I still take 2 points off. How much are the homeworks worth? They're worth 5. So look, what if you turned it in late, you tore it out of a notebook, you did it in pen, you didn't put the section number, and you only put your first name? That means you owe me a point, right? 1, 2, 3, 4, 5, 6 out of 5, right? So that would be a 0 if you did that. I know it sounds crazy. I know it sounds just ridiculous, but I want you to learn how to follow instructions. Following instructions is like the most important thing you could do. Well, one of the most important things. So I want you to follow instructions, and if you can follow instructions, you should get 5 out of 5s on here. I don't grade the homework problems if they're right or wrong. I just grade on completion, okay? So, but you got to try. You got to at least show some effort. Now, with this first lesson, there's really not a lot of work to show. There may be on a few problems, all right? Most of these problems, I think, you're just writing answers, okay? But once we start really getting into it, and you have to show your work, you definitely need to do that all the time. By the way, once we get to the lessons that you have to show your work, if you don't, like I gave worksheets to a couple geometry classes, and it was all just algebra stuff as a review. And I told them, I said, you got to show how you got the answer. You wouldn't believe how many people didn't do it. And I actually took off -3 because they didn't show their work. All they did was just write down a bunch of answers, and they probably wrote them down after I read them off to them. But anyway, it's easy to get a 5. Doesn't look like it here. But if you just follow instructions, it's super easy. All right, get that done for tomorrow.